So we had to answer 5 questions about the equation f of t equals 110e to the power of negative 0.08t plus 75. So the first question is, explain using the structure of the expression f of t equals 110e to the negative 0.08t plus 75, why the coffee temperature decreases as time elapses. So the negative is multiplied by a positive, which is time, because you can't have negative time. So it's always going to be a negative multiplied by a positive, and that's going to create a bigger negative number, so really a smaller number. So when negative 0.08 is multiplied by a large positive number, the answer will become smaller. The longer the coffee sits out, the colder it becomes, just logically. So overall, the coffee temperature decreases as time elapses because the exponent is negative. If it was positive, then it would be a larger number, but it's negative, so it gets smaller. So the second question is, what is the temperature of the coffee at the beginning of the experiment? So at the beginning of the experiment, no time has passed. So we plug in 0 for time. So that's going to be in the exponent. So it's going to be f of t equals 110e to the negative 0.08 times 0. And anything to the power of 0 equals 1. So that's going to be 110 times 1 plus 75. And then that's going to be 110 plus 75. And at the beginning of the experiment, the coffee is 185 degrees Fahrenheit. So the third question is, describe the domain and range in the context of the problem. So I just made a rough sketch of the graph. And for the domain, it's going to start at 0 because you can't have negative time in a real world problem. So it starts at 0 and it goes on to negative infinity because the coffee could sit out for an infinite amount of time. And for the range, the starting temperature of the coffee we found out from the first problem is 185 degrees. So there's a bracket at 185, and room temperature is 75 degrees. So it can't get any colder than room temperature, so there's also a bracket at 75 degrees. The fourth question is, how hot is the coffee after 1 minute? Use algebra to show your work. So 1 minute is time, so we're plugging it in for t again. And so f of t equals 110e to the negative 0.08 times 1. And so that's just going to be 110e to the negative 0.08 plus 75. And then 110e to the negative 0.08, if you plug that into your calculator, that equals 101.54. And then you add 75. So after a minute, the coffee is at 176.54 degrees Fahrenheit. So for the fifth and final question, it asks, after how many minutes is the coffee 100 degrees? Use algebra to show your work. So 100 degrees is the temperature, so we plug that in for f of t, and that is 100 equals 110e to the negative 0.08t plus 75. We subtract 75 from both sides. You get 25 equals 110e to the negative 0.08t, and then we divide by 110 to get e to the negative 0.08t by itself. We divide by 110 on both sides. Then we have 25 over 110 equals e to the negative 0.08t. Then we take the natural log of both sides, and that cancels out the e, so it's just negative 0.08t equals natural log of 25 over 110, and that equals negative 1.48 equals negative 0.08 t. And then the negatives cancel each other out, so they're both positive. And then we divide by 0.08 on both sides so we can get what the time is. So 1.48 divided by 0.08 equals 18.5. So when the coffee reaches 100 degrees, it will have been left out for 18.5 minutes. And those are all the problems. So work for that one. My work for this one. And work for this one.